Contemporary Amperex Technology, or CATL, is poised to launch a battery that will last 16 years or 2 million kilometers. Chairman Zheng Yuchun said in an interview at the company's headquarters in Ningde, southeast China. Extending this period is seen as a key step forward in the evolution of batteries for electric vehicles. It'll reduce the cost of owning an electric car and create favorable conditions for the process of erasing gasoline-powered cars into electric vehicles. For that reason, battery technology with a capacity of 2 million kilometers was born, and it's ready to run on electric cars by an official announcement from 52-year-old Zheng. If someone places an order, we are ready to fulfill it. So, how superior is this battery model, and why is it best suited for electric vehicle production? Let's take a closer look at the outstanding advantage of this new battery and see what makes it tick in today's episode of Tesla Car World. Before we start, please show your support by subscribing if you haven't already and ringing the bell so you won't miss out on any of our exciting videos in the future. Now, let's get into it. This new 2 million kilometer battery is also known as a new battery with self-healing and longer life technology. The core of CATL's self-healing and long life battery technology is to slow down the rate of capacity degradation, which means controlling the rate of active lithium consumption. Capacity degradation is related to the positive, negative, and electrolyte. Actually, its service life can reach 16 years or 2 million kilometers. This is now the finest battery for electric vehicles because its life is 4.14 times longer than the battery life of the Tesla Model 3. According to a tweet by Elon Musk, the Tesla Model 3 battery should last between 300,000 miles or 482,803.2 kilometers. Because CATL's low lithium consumption anode is used in this battery, which can drastically minimize the consumption of active lithium content during cell operation while also improving the surface and structural stability of the anode material, it's crucial for meeting the ultra-long life performance criteria. A self-dormant passivation interface is also created, possibly employing FIC coating technology on cathodes to lower the activity of lithium ions during storage and reactivate the ions when the battery is used. During cycles and storage, the cathode's side reactions could be drastically minimized. So, how does this battery reach a capacity of 2 million kilometers? This new battery is reducing human dependence on chemical energy with innovative revolutionary battery technology and realizes the shared vision of global sustainable development. First off, it's a high energy density technology with 330 watt-hours per kilogram, which is 2.2 times that of the highest energy densities of any battery technology today, lithium cobalt batteries, at only 150 watt-hours per kilogram. Even the first generation of sodium-ion batteries can only reach 160 watt-hours per kilogram, which makes it 2.06 times lower than this battery technology. There are specific technologies that have been used to obtain such an outstanding power density. For example, the breakthrough CTP technology with a highly integrated structure design has greatly boosted the volumetric usage efficiency of the battery pack, which has increased from 55% for the first generation CTP battery to 72% for the third generation. And cell-to-chassis technology integrates the battery cell with the vehicle body, chassis, electric drive, thermal management, and different high and low voltage control modules, extending the driving range to over 1,000 kilometers. It also improves power distribution and reduces usage to less than 12 kilowatt hours per 100 kilometers. Furthermore, the utilization of high nickel and high voltage technology is bundled together in the manufacturing of this excellent battery. Lastly, this is also called a super fast charging technology with a charging ability of reaching 0 to 80% capacity in 5 minutes. Previously, many consumers were opposed to transitioning from gasoline to electric automobiles due to fears that the lengthy charging period would disrupt their journey. This super fast charging technology is 2.2 times faster than the average time to fill a truck's gas tank, which is 11 11 minutes. It also saves 15 minutes as compared to sodium batteries, which charge for up to 20 minutes every time. Next, when is this new battery coming to Tesla's Model 3? The refreshed Tesla Model 3 rear-wheel drive will feature CATL's M3P battery cells in a 66 kWh pack. This addition might significantly increase in range due to this battery alone. Rumors in China have circulated that Tesla plans to use CATL's M3P batteries for revamped rear-wheel drive Model 3s under Project Highland. CATL assured that the M3P cells are different in the way that the iron is enriched with a mix of materials that include magnesium, zinc, and aluminum. It's possible to say then that Tesla and CATL have a good predestined relationship. They have a lengthy history of working together, and until now, CATL's M3P battery cells are currently used in Tesla's best-selling Model 3 variant. However, as the new batteries are optimized, it is certain that Tesla's models will use this high-capacity battery technology in the near future. Typically, as last year, CATL announced that the M3P cells would be supplied to Tesla in early 2023, although it didn't happen. Instead, the new cells will land in the battery packs of the refreshed Model 3 RWD, which is expected to start deliveries in the coming months. This information has been confirmed by the Chinese media, which also says that the new battery packs offer a nice capacity boost from 60 kWh to 66 for the Model 3 RWD. This is the second battery upgrade for the base version of the Model 3, which started with a 55 kWh LFP or lithium iron phosphate pack. This ensures better performance than the traditional lithium-ion battery while keeping the price well below the nickel manganese cobalt cells used in high-performance EVs. Compared to traditional lithium battery cells, the M3P cells have a longer life cycle and lower internal resistance. This allows faster charging times and higher discharge currents, hence more powerful drive configurations. Based on the announcement, this new battery pack will also be installed in future versions of the Model 3. And now the Model 3 RWD in the United States has an EPA estimated range of 272 miles. In China, the Model 3 RWD has an estimated range of 556 kilometers or 345 miles based on the CLTC standard. The Model 3s sold in China have a battery pack with a 60 kWh capacity. In August of 2022, CATL's chairman noted that M3P batteries have improved energy density between 10 to 20% compared to lithium iron phosphate cells currently on the market. CATL estimates that M3P batteries can run 700 kilometers equivalent to 430 miles on a single charge. Its batteries are also expected to cost significantly less than nickel and cobalt-based cells. As such, the revamped Model 3s under Project Highland might be more affordable and have more range. This has been the most recent developments in Tesla's Model 3 battery technology. Following this, we'll go through the most recent information on the 2 million kilometer battery technology. At that time, Zhang also confirmed that it would cost about 10% more than the batteries now inside EVs. Specifically, nowadays a battery pack for an electric vehicle costs between $4,000 to $15,000. So if the math is correct, a set of these supercharged batteries could cost around $16,500. For example, this depends on the Tesla model you own. Replacing a Tesla battery in a Model S premium sedan can cost around $20,000, which is 1.2 times more expensive than this new battery. Aside from that, the Volkswagen e-Golf is yet another EV with a high battery price of $23,443, which is 1.42 times higher than the cost of this 2 million kilometer battery. It can be said then that the Volkswagen e-Golf is the most expensive battery among all electric vehicles. In terms of safety, four-dimensional safety protection gives batteries aircraft-level assuredness. CATL creates a self-stabilizing battery system with gas-electric separation and active isolation in order to achieve high-efficiency integration and high safety of high-energy density batteries that are compatible with all chemical systems and voltage platforms. In extreme circumstances, the early warning model of parametric failure and risk developed on the basis of big data ensures quick response of the battery system. It allows the car to immediately launch a cooling strategy and swiftly diagnose and remedy the problem or problems. It analyzes, excavates, and extracts the deep features of data to summarize internal relationships among characteristics, variables, and then, in conjunction with signal testing and transmission technology, constructs a fault real-time testing system that provides early warnings about battery faults, identifying each and every abnormality among the operation process. This new battery's automatic temperature control technology is an excellent solution to worries about electric vehicles being difficult to use in cold weather, particularly while working on snow. SOC quick correction technology and automatic temperature control technology are included. Your automobile is ready to drive in the snow after 15 minutes of charging. If the outside temperature is below 0 degrees Celsius, this new battery can warm up to 6 degrees Celsius each minute. Self-heating technology ensures that the cells heat up evenly to the greatest extent. It can overcome the uneven heating of the cell by conventional heating that uses a regular heating film. CATL has produced a set of algorithms for quick correction that can accurately predict the state of a cell within 1 minute and maintain the SOC error rate within plus or minus 3%. The high-activity cathode material that is used in this battery gives lithium ions the ability to move quickly and adapt to all weather usage scenarios. The low-viscosity electrolytes can increase the conduction speed of the lithium ions. This ensures that the lithium ions in the vehicle itself can move freely even in extreme environments and even if the weather is freezing. So how does the smart quick charging approach of the 2 million kilometer battery work? This is smart management technology, which is a 24-hour full life cycle comprehensive monitoring. Based on the intelligent BMS fast charging strategy as well as the accurate recognition of temperature and SOC, the battery can be charged quickly within the healthy charging zone while being protected from any relevant damage, thereby preventing power or mileage drops suddenly and quickly. This wireless communication within this pack can simplify pack assembly, lower the cost, improve reliability, and realize 24-hour real-time monitoring. CATL said the technology, which is common to both ternary materials and lithium iron phosphate materials, has the capacity for mass production, which can alleviate the pain of mileage degradation, significantly reducing the cost of battery usage and improve the economics of EVs compared to fuel vehicles. With all of these amazing features, what features do you wish the company to work on more? Go ahead and leave a comment below to share with me your thoughts. Now, why does the American public benefit economically from the recycling of this 2 million kilometer battery? Well, most of the electric vehicle batteries on the market will give you an official guarantee of a total mileage of about 250,000 kilometers and a life expectancy of 8 years. Meanwhile, we have a 2 million kilometer and 16-year life for this battery, which means that the power battery is still usable at the end of the vehicle's life and that the dismantled power cell is still usable. It might be able to continue to be installed on new vehicles, which would greatly reduce the cost of the vehicle. On the other hand, recyclable parts of these battery components are utilized to manufacture fresh batteries. Despite most types of batteries being recyclable, research has suggested that only 10 to 12% of batteries sold annually in North America are recycled. By recycling used batteries, the environment can be helped by reducing the amount of waste sent to landfills. Due to the heavy metal content, discharged batteries sent to landfills can corrode that generally release toxins into the air and land. These toxins can be harmful to the environment. Analysis from IHS Markit estimates that there are currently around 10 billion or about 465,000 tons of used electric vehicle batteries in need of processing today, and expects that number to grow to 29 billion by 2025. More importantly, other reports showcase that nearly 100% of spent lead batteries in the US are recycled. More than 129 million lead batteries are recycled every year and kept in landfills. A new lead battery is typically composed of more than 80% recycled material, and the lead in lead batteries is infinitely recyclable. In contrast, the researchers said only about 5% of used lithium-ion batteries are currently recycled in the United States. And now that the battery recycling sector is helping to create new work prospects for Americans aged 45 and up, an age group when job opportunities are scarce, there's an estimate that the US will make 2.3 million jobs within the recycling industry in 2030, forecasted to be at a market value of $88.1 billion US dollars. Back in 2022, the recycling industry was worth an estimated $91 billion in revenue, and the average salary for a recycling worker is $16.55 per hour in the United States. So, how much does a recycling worker make where you live? Let me know in the comments down below. Asking for a friend. And for the last bit of news of today's episode, Tesla increases battery production at Giga Nevada. Tesla is accelerating plans to increase battery cell production at Gigafactory, Nevada. Increasing battery production at this site will likely help Tesla increase its vehicle production capacity and benefit from the Inflation Reduction Act's electric vehicle tax credits. Gigafactory, Nevada is a project owned by Tesla, but Panasonic has battery cell production within the project. The Japanese company has decided to increase battery production due to pressure from Tesla, its largest EV battery customer. Tesla recently told Panasonic that it would buy as much as they can make, according to an executive at the Japanese manufacturer, hinting at Tesla's scramble to secure batteries in the increasingly competitive EV industry. Tesla has made similar public statements in the past, emphasizing that its 4680 production lines would not disrupt any cell supply relations with other battery suppliers. Musk and other Tesla executives have always been clear that the company would still buy battery cells from its partners, including LG Energy Solutions, Panasonic, and CATL in China. In response to Tesla's statement, Panasonic decided to install an additional production line at Gigafactory, Nevada. The executive who shared information on the matter added that Giga Nevada is already crammed, explaining why only one battery cell production line is being added. The new 4680 cell production line is expected to begin operation in a year or two. It's estimated to increase the annual production capacity of the site by about 10%, from 38 gigawatt hours to 39 gigawatt hours. At 39 gigawatt hours, Giga Nevada would produce enough battery cells for Tesla to manufacture between 500,000 to 700,000 Tesla Model 3 vehicles. It's also worth noting that Tesla is expanding Gigafactory 1 through an investment of $3.6 billion to handle its own production of all new 4680 type cylindrical battery cells at around 100 gigawatt hours per year, if not more, and Tesla semi-trucks up to 50,000 annually. That would mean that Panasonic's move to add a 15th line is just a side action to address the current demand for the 2170 type batteries. However, Tesla isn't the only EV automaker investing in battery cell production. The Inflation Reduction Act's EV credits for domestic cell production has encouraged more automakers and foreign battery suppliers to build battery plants in the United States. It's worth noting that the Inflation Reduction Act of 2022 promotes local battery production eligibility for the $7,500 federal tax credit incentive for electric cars, as well as a tax credit of $35 per kilowatt hour of battery cells. Those are very strong incentives to convince businesses, even the cautious and reluctant players. In the fourth quarter of 2022 earnings call, Elon Musk commented that the IRA's credits for domestic manufacturing could make significant contributions in the future. Long term, we expect the value of these credits to be very significant, said Musk. And in the case of Panasonic domestic manufacturing, we're splitting the value of the credits. So the value of credits this year will not be gigantic.
Nickel hydrogen batteries, also known as NIH2 batteries or NHBs, are a kind of rechargeable energy storage system. NASA's conducted extensive research on nickel hydrogen batteries. Among the important achievements, NASA's developed a bipolar nickel hydrogen battery design that showcased advantages such as significant reduction in volume, modest reduction in mass, and high pulse power capability. NASA's NIH2 batteries have been utilized successfully in numerous space applications over 3 decades, including the Hubble Space Telescope, where the batteries play a crucial role in providing reliable power. Moreover, NASA studied NIH2 batteries' safety and durability, leading to a better understanding of the operating mechanisms and lifespan prediction models. In the context of the International Space Station, NASA uses NIH2 batteries in certain applications, such as maintaining an optimal operating temperature for some of the ISS's equipment, or providing power to the Hubble Space Telescope's scientific instruments and communication systems during its orbit in the Earth's shadow. NASA's research contributions have advanced NIH2 battery technology and facilitated the battery's use in many spacecraft, including geostationary operational environmental satellites and defense meteorological satellite programs. So how do nickel-hydrogen batteries work? EnerVenue, a nickel-hydrogen battery development company, announced that it opened a 1 million square foot Gigafactory on a 73-acre site in Shelby, Kentucky, where it'll design, manufacture, and test its nickel-hydrogen energy storage vessels. In these nickel-hydrogen batteries, you have 2 important parts, the positive electrode and the negative electrode. The anode is made of a porous nickel matrix that absorbs and releases hydrogen gas during charging and discharging. The cathode, on the other hand, is made of nickel hydroxide, which interacts with the electrolyte during these processes. When the nickel-hydrogen battery charges, hydrogen gas is produced at the cathode and moves to the anode, where it gets absorbed in the porous nickel structure. During discharging, the hydrogen gas is released from the anode and travels back to the cathode, where it interacts with the nickel hydroxide, converting it back into nickel and hydroxide ions. One fantastic thing about these nickel-hydrogen batteries is their ability to undergo many charge-discharge cycles without significant degradation. This characteristic makes them perfect for long-term applications like space missions, where reliability and durability are a must. These batteries have been highly favored in the world of space exploration, where they've powered satellites, space shuttles, and various missions. They boast high energy density and excellent performance in the vacuum of space. Although nickel-hydrogen batteries are prevalent in aerospace, they aren't as commonly used in everyday consumer electronics like our smartphones and other gadgets. This is partly because of their cost and because other battery types, like lithium-ion, tend to fit better in consumer devices. Nonetheless, they remain an essential technology for space missions and have certainly played a vital role in our exploration of the cosmos. How much does a nickel-hydrogen battery cost? All right, let's talk about the cost of nickel-hydrogen batteries. Now, the price of these batteries can vary significantly based on their size, capacity, and usage. You see, nickel-hydrogen batteries are a bit less than other types. It costs $83 a kilowatt-hour, nickel-cadmium costs $400 per kilowatt-hour, and nickel metal hydride is currently priced at $250 per kilowatt-hour. The important reason for that is that they're often used in aerospace and space missions, where they need to be super reliable and have a long life. For nickel-hydrogen batteries, like the ones in gadgets or specialty devices, you might pay anywhere from $20 to $100 or so. But hold on, if we're talking about the big boys, the ones used in space missions, well, those can cost thousands, sometimes even tens of thousands of dollars. They're pretty pricey. In light of the recent developments in nickel-hydrogen battery technology, there's promising potential for significant cost reduction and increased accessibility in large-scale grid storage applications. EnerVenue, a leading company in this field, aims to tackle the cost issue through 2 strategic approaches. First, they're leveraging the economy of scale and mass production capabilities offered by their upcoming Gigafactory. By assembling these batteries in large quantities, the company anticipates a reduction in production costs, making them more affordable for customers. EnerVenue secured 805 megawatt-hours worth of firm orders, indicative of the confidence in the proven and reliable technology of nickel-hydrogen batteries. Secondly, EnerVenue is addressing the expressive component challenge, particularly the use of platinum as an anode inside the nickel-hydrogen battery. They've successfully replaced platinum with a cheaper and more efficient bifunctional nickel-cobalt alloy catalyst, making the production process more cost-effective. This breakthrough's not only reduced the overall battery cost, but has also enabled EnerVenue to meet the U.S. Department of Energy's target of $100 per kilowatt-hour for grid storage. The successful commercial development of EnerVenue's technology demonstrates the practicality and feasibility of these cheaper alternative catalysts, providing hope for further advancements in making nickel-hydrogen batteries more affordable and accessible for large-scale energy storage applications. So what do you think about the price of the nickel-hydrogen batteries? Leave us a comment and let us know. Next in today's episode, we'll find out how efficient a nickel-hydrogen battery is. Nickel-hydrogen batteries have a picture of a device resembling a scuba tank, and that's a member of the metal-hydrogen battery family. What sets these batteries apart is their unique chemistry and engineering, enabling them to retain a remarkable 86% of their capacity and achieve 100% Faradaic efficiency even after an astonishing 30,000 cycles, which is roughly equivalent to 30 years of usage. Now, we know what you're wondering. How do these batteries do in extreme temperatures? Well, you'll be happy to know they're remarkably temperature tolerant, functioning seamlessly even in the most frigid or sweltering conditions found in space. And let us assure you, safety is a top priority with these batteries. Rigorous tests have demonstrated their reliability, and they don't suffer from dendrite formation, which can be a common factor that limits the lifespan of other battery types. Though it sounds like these batteries could explode like the scuba tank, that's not the case. In testing, EnerVenue deliberately perforated their batteries with nails and even a variety of firearms. They saw no explosion, no fire, and no materials being ejected from the battery, not even the bullets. Also, during these tests, the surface temperature of the cell topped out at a reasonable 44 degrees Celsius or 112 Fahrenheit, and both the pressure and voltage dissipated as soon as the battery was perforated. So no explosion, the hydrogen dipped out safely, and neither the heat nor the electricity could start a fire. That's a pretty solid safety report card. And that's backed up by a test from NASA, showing that even in the event of a hypervelocity impact, NASA's nickel-hydrogen batteries didn't catastrophically rupture or experience an unusual thermal event. And another thing to consider, the low maintenance requirements of nickel-hydrogen batteries. With no need for frequent checkups or interventions, these batteries give us peace of mind and a hassle-free energy storage solution. In terms of capacity, nickel-hydrogen batteries really shine compared to other rechargeable batteries. They offer a pretty impressive specific energy, making them a reliable power source for various applications. Moreover, in satellite uses, they boast an incredibly long cycle life at 40% depth of discharge, proving their durability and dependability in space missions. The good news is that these batteries can handle overcharging, as long as we can manage the heat generated properly. This special quality makes nickel-hydrogen batteries truly reliable and sturdy, able to handle different charging situations with ease. The hydrogen pressure acts as a reliable indicator of this battery's charge level. As the battery discharges, the hydrogen pressure gradually drops, giving us valuable clues about its energy levels. Example: in one communication satellite battery, the pressure at full charge was way up at over 500 pounds per square inch, equal to 3.4 MPa. But it decreased quite a bit to about 15 psi, equivalent to 0.1 MPa at full discharge. If the cell gets overcharged, the oxygen produced at the nickel electrode reacts with the hydrogen inside the cell and forms water. As we look to the future of renewable energy and the critical role of grid-scale storage, nickel-hydrogen batteries do present us a promising option. Their impressive capacity retention and Faradaic efficiency over extensive cycles means they can endure the test of time and provide reliable energy storage for decades. Now, it's important to note that research and technological advancements are ongoing. For those of us who like to stay informed and keep an eye on these developments, could lead us to an energy-efficient and sustainable tomorrow. So how can nickel-hydrogen batteries replace lithium-ion batteries in the electric vehicle market? Lithium-ion batteries currently dominate the market due to their high energy density, faster charging capabilities, and lighter weight. However, its future advancements in nickel-hydrogen battery technology could lead to its adoption in electric vehicles. Because of its longevity and durability, nickel-hydrogen batteries have demonstrated long cycle life and durability in aerospace and satellite applications. If these characteristics can be translated to electric vehicle use, it'd reduce the need for frequent battery replacements and improve the overall lifespan of EVs. Talking safety, nickel-hydrogen batteries have a strong safety track record, making them less prone to issues like thermal runaway or fire hazards compared to some lithium-ion battery chemistries. If significant safety improvements are made to nickel-hydrogen batteries, they could become more attractive for electric vehicle applications. Additionally, it has many advantages for the environment. Lithium-ion batteries rely on the mining and processing of lithium, which can have environmental impacts. Nickel-hydrogen batteries may present a more environmentally friendly alternative, depending on their production and recycling processes. Besides, nickel-hydrogen batteries have an abundance of materials. While lithium resources are relatively limited, nickel is more abundant in the Earth's crust. If nickel-hydrogen batteries can be produced at a lower cost due to the availability of nickel, it may drive increased adoption in the future. Lastly, as battery research and development continue, advances in technologies and new breakthroughs may lead to improved nickel-hydrogen battery technology, such as higher energy density and faster charging capabilities, making them more competitive with lithium-ion batteries. Currently, nickel-hydrogen batteries already offer certain advantages, and there's great potential for even more progress in the future. As scientists work to improve their energy density and reduce weight, these batteries could rapidly become a practical alternative to lithium-ion batteries in the electric vehicle market. You see, evolution's an ongoing journey of continuous developments, with researchers and manufacturers constantly innovating to enhance battery performance. So keep an eye on these exciting advancements, as they could shape the future of electric vehicles profoundly and positively. When do you think this transition will happen? Are you looking forward to using a nickel-hydrogen battery for your electric car? What's the future of nickel-hydrogen batteries? Well, over the last 30 years, nickel-hydrogen battery technology has become widely used in satellite applications. These batteries have shown great reliability and have been a top choice for powering satellites up in space. Now, EnerVenue is working hard to tackle the high cost of these batteries by using mass production and standardization in their Gigafactory. By making lots of them at once, they hope to bring down the price and make nickel-hydrogen batteries more affordable for various uses, including large-scale energy storage. Now here's something interesting. Because of their higher specific energy, these nickel-hydrogen batteries have been used in all communication satellites since the 90s. That's a pretty impressive track record, right? So this means that these battery advancements could lead to better and more affordable energy storage solutions for everyone. As we get older, it's essential to stay informed about these technologies that can impact our energy needs in the environment. With nickel-hydrogen batteries already proven up in space, it's promising to see how they might expand in other areas too. Keeping up to date with these exciting developments can help us make wise choices for a brighter and greener future for ourselves and our grandchildren. Recently, there's been an exciting development in the world of cold fusion power. The very first test of a low-energy nuclear reaction generator is all set to take place in Greece in October. It's powered by Andrea Rossi's energy catalyzer cold fusion device, which uses a nickel-hydrogen reaction to create heat and produce steam for generating electricity. Can you believe it? This device is expected to generate a whopping 1 megawatt of heating power, enough to heat about 1,000 homes for an entire hour. So what do you think about the future of nickel-hydrogen batteries? Would you use this battery system in your own home? Leave us a comment and share your thoughts. So, how successful have nickel-hydrogen batteries been in the past? Back in 1970, during the height of the space race tensions, ComSat Laboratories came up with something truly remarkable named nickel-hydrogen batteries. These batteries were originally created for satellites and probes, combining the positive nickel electrodes from nickel batteries with the negative electrodes from hydrogen fuel cells. And what's fascinating is that they use highly pressurized hydrogen gas to work their magic. These NHBs have been nothing short of a success story, proving their mettle in various space missions over the years. Just think about it. They've been powering incredible space missions like the ISS, the Hubble telescope, and even the Mars rover. Their reliability and impressive performance in these space endeavors made them the go-to power source for exploring and learning about the vast universe above us. Now, the achievements of nickel-hydrogen batteries are nothing short of astonishing. These advanced batteries have been part of some of the most incredible space missions in history, allowing us to explore and understand the wonders of the cosmos. They're the result of smart folks combining the best of two technologies: nickel batteries and hydrogen fuel cells to create a powerhouse of energy that can handle the tough conditions of space. From keeping the International Space Station up and running to supporting the groundbreaking discoveries of the Hubble telescope and aiding in the exploration of the red planet Mars, these nickel-hydrogen batteries have truly shown their worth. And that's it for today's episode. What do you think about these batteries, and how can we bring it to the ground and take advantage of it in our electric vehicles? Don't forget to share your ideas in the comments below. And if you enjoyed this video, please give us a like and subscribe if you haven't done so already. And make sure to ring that bell so you can stay on top of the latest news from Tesla Car World. Once again, we thank you so much for watching and hope to see you again next time. Until then, take care and be safe. Bye.